China's submersible is carrying out its latest mission at the Mariana Trench in the Pacific Ocean. This is the fourth time the watercraft known as Striver has successfully dived more than 10 kilometers.
9 miles down, the ocean becomes so heavy it can crush a steel hull the way you'd crush a soda can. January 23rd, 1960. 2 men are sealed inside a steel sphere no bigger than a small car, descending into the deepest place on the surface of our planet. No sunlight has ever reached that depth. No sunlight ever will. Before we descend into the deepest place on Earth, hit like and subscribe, because the closer we get to the ocean's greatest mysteries, the stranger they become. About 30,000 feet into the descent, they hear it. A crack. The outer window, the only barrier between them and enough pressure to kill them both in less than a second, has fractured. And here's the part that should stop you cold. They don't turn back. They keep sinking. What they discover during the 20 minutes they spend on the seafloor is still debated by scientists more than 60 years later. And that historic dive was only the beginning. Over the next 6 decades, the US Navy, Japan, and some of the world's leading ocean research teams kept sending machines, and eventually people, back into the same trench. Some of those missions returned with discoveries nobody expected. Others never came back at all. By the end of this video, you'll understand why the deepest place on Earth keeps challenging everything we think we know, and why every expedition, even the successful ones, includes a period when nobody on the surface knows what's happening thousands of feet below their ship. Why the trench breaks everything. Before we get back to that cracked window, you need to understand exactly what 9 miles down actually means, because your brain is probably underselling it right now. The Mariana Trench sits in the Western Pacific, near Guam. Its deepest known point is called the Challenger Deep, and it drops to roughly 10,900 to 11,000 meters below sea level, depending on which survey you trust, since even measuring it precisely is its own kind of engineering problem. Put Mount Everest into that trench, base to peak, and you would still have more than a mile of water sitting on top of the summit. That's the scale we're talking about. Now let's talk about pressure, because pressure is the actual villain in every story you're about to hear. At sea level, the air around you pushes down with about 14.7 pounds per square inch. You don't feel it because your body's pushing back with equal force. At the bottom of the Mariana Trench, that number jumps to somewhere around 16,000 pounds per square inch. That's the equivalent of an adult elephant standing on your thumbnail. Multiply that elephant by roughly 1,000. Add total darkness. Sunlight stops penetrating seawater in any meaningful way past about 1,000 meters, so the last 10 kilometers of that descent happen in absolute black. Add near freezing water, hovering just above freezing point year-round. Now you understand why building something that can survive down there and come back isn't really naval engineering. It's closer to building a spacecraft, except instead of protecting against a vacuum trying to pull things apart, you're protecting against a wall of water trying to crush things flat. Here's a number that puts this whole video in perspective. More human beings have walked on the surface of the moon than have ever reached the bottom of the Mariana Trench. Every single attempt you're about to hear about was, and still is, one of the rarest things a person or a machine can do. So with that in mind, let's go back to 1960 and that cracked window. The Trieste, 1960. The vessel was called Trieste, but it wasn't a typical submarine. It was a bathyscaphe, a deep-sea craft designed specifically for exploring the ocean's greatest depths. At the top was a huge tank filled with about 130,000 liters of gasoline, which provided buoyancy because gasoline is lighter than water and doesn't compress easily under extreme pressure. Suspended beneath it was a small steel sphere, just large enough for 2 people, built to survive the crushing force found at the bottom of the ocean. Trieste was designed by Swiss engineer Auguste Piccard and later operated by his son, Jacques Piccard. In 1958, the U.S. Navy acquired the vessel to explore parts of the ocean no one had ever reached before. On January 23, 1960, Jacques Piccard and Don Walsh climbed into the tiny steel capsule and began their descent toward Challenger Deep, the deepest known place on Earth. Hours into the dive, at nearly 30,000 feet, one of the outer acrylic windows developed a crack. At that depth, even a small failure could have been catastrophic. Yet after carefully assessing the situation, the crew decided to continue because turning back would have taken nearly as long as completing the descent. Eventually, they reached the sea floor at a depth of about 10,911 meters, setting a world record. They remained there for only 20 minutes before beginning the return journey because of the damaged window. During their brief stay, both men reported seeing what looked like a flatfish resting on the seabed. The observation has remained controversial ever since. Some scientists argue that a fish with a swim bladder couldn't survive under such extreme pressure, while others suggest they may have seen a different type of deep-sea animal. Since there were no photographs or physical evidence, the sighting has never been confirmed or disproven. What the Trieste mission unquestionably proved was that humans could reach the deepest part of the ocean and return safely. It also highlighted just how dangerous such missions were. A single failed window could have ended the expedition instantly, and at that depth, rescue would have been impossible. Because of the enormous technical challenges and costs involved, it would be many years before another expedition ventured back to the bottom of the world's deepest ocean. Kaiko, 1995 to 2003. That machine came from Japan. In March of 1995, a remotely operated vehicle named Kaiko, built by the Japan Agency for Marine Earth Science and Technology, became only the second craft in history to reach the true bottom of the Mariana Trench. It touched down at 10,911 meters, matching, almost to the meter, the depth the Trieste had reached 35 years earlier. Kaiko was nothing like the Trieste. It carried no crew at all. Instead, it was lowered from a surface ship using 2 connected cables, a launcher vehicle that stayed higher in the water column, and a smaller diving unit that carried the cameras and sampling tools down to the seafloor itself. The whole system weighed over 10 tons, and it needed both pieces working in tandem to survive the pressure and make the trip safely. Over the next 8 years, Kaiko didn't just visit the trench once and retire. It completed more than 250 dives across the world's oceans, more than 20 of which reached all the way to the Mariana Trench floor. This was the first time in history that scientists could send something back to that depth again and again instead of treating it as a once-in-a-generation achievement, and the discoveries piled up. Kaiko collected sediment samples straight from the trench floor. It filmed crustaceans and worms living their entire lives in total darkness, at pressures that would have killed a human being instantly. It pulled up deep-sea bacteria that researchers later studied for potential medical applications. In 2000, it discovered an entirely new hydrothermal vent system on the floor of the Indian Ocean, an underwater ecosystem nobody knew existed. A year before that, it had located the wreckage of a failed Japanese rocket launch sitting quietly on the seafloor near the Ogasawara Islands. Kaiko had become, without much fanfare, the most experienced deep trench vehicle that had ever existed. Then, on May 29, 2003, everything changed. Kaiko was working in a different part of the Pacific in the middle of a typhoon when the secondary cable connecting it to its launcher snapped. Investigators later determined that the steel fibers inside that cable had been quietly weakening for years, worn down by repeated bending under extreme pressure until the failure point simply gave way all at once. Kaiko sank. It was never recovered. Japanese researchers searched the surrounding waters for weeks. Nothing came up. The vehicle that had visited the deepest place on Earth more than 20 times was simply gone. And there was no camera footage, no black box, no clean explanation available in the moment it happened, only a snapped cable and an empty patch of ocean. For the team that had spent nearly a decade with Kaiko, that loss meant something bigger than one broken machine. It meant the most experienced deep trench vehicle on the planet had vanished with almost no warning, and it set up a very specific problem for whoever tried this next. How do you avoid losing everything the moment a signal goes dark? The answer would come from a new generation of machines built to solve exactly that. Nerius, 2009 to 2014. In 2008, the Woods Hole Oceanographic Institution finished building a vehicle designed to answer that exact question. They called it Nerius, a name chosen through a nationwide contest among students and researchers, borrowed from a Greek sea titan often described as having a man's torso and a fish's tail. Nerius was built with a specific advantage nobody had fully achieved before. It could operate either on a thin fiber optic tether, streaming data and video back to the surface in real time, or completely on its own, untethered when the mission called for it. Engineers packed the vehicle with technology nobody had risked at this depth before. Lightweight ceramic flotation material instead of traditional syntactic foam, and lithium-ion batteries powerful enough to survive the full round trip. On May 31, 2009, Nerius became the third vehicle in history to reach the bottom of the Mariana Trench, touching down at 10,902 meters. But this dive was different from every trip before it, in a way that mattered enormously. Nerius didn't just touch bottom and leave. It stayed on the seafloor for more than 10 hours, and it streamed live video the entire time. For the first time ever, scientists on the ship above weren't waiting hours or days for a vehicle to resurface with recorded footage. They were watching the bottom of the ocean unfold on a screen in real time as it happened. Nerius went on to explore the deepest known hydrothermal vents ever found, located along the Cayman Trough in the Caribbean. Proving its usefulness went well beyond the Mariana Trench alone. By 2014, Woods Hole had scheduled Nerius for a return trip to the Mariana Trench that November as the centerpiece of a larger research effort called the Hadal Ecosystem Studies Project, a program built specifically to understand how life survives in the coldest, most crushing, least explored parts of the ocean. That plan never happened. Something stopped it months earlier, in a completely different trench, in front of the very team that had built the vehicle. On May 10, 2014, 30 days into a 40-day mission exploring the Kermadec Trench near New Zealand, Nerius was working at a depth of 9,990 meters. About 7 hours into what was supposed to be a 9-hour dive, communication with the surface simply stopped. The live video feed cut. Every signal from the vehicle went silent at once. Just minutes before that happened, Nerius had finished collecting a sea cucumber for one of its onboard experiments and was preparing to head back toward its recovery platform. It was, by every indication, in the middle of a completely routine end to a completely routine dive. For a stretch of time after the signal died, nobody on the ship knew what had happened. Standard emergency recovery signals got no response. The crew began scanning the surface nearby and eventually spotted floating debris in the water. Once that debris was recovered and examined, it confirmed the worst possibility. A portion of Nerius had imploded under pressure, reaching roughly 16,000 pounds per square inch. More than 1,000 times the pressure felt at sea level. Nerius was gone, and with it went the November plan to send a live camera feed back into the Mariana Trench. Woods Hole's research director later called the loss a stark reminder of exactly how much risk comes with working at these depths. Risk that no amount of engineering experience can fully eliminate. One of the biologists who helped design the vehicle put it differently. Nerius, she said, had let researchers ask questions about the deep ocean that nobody had even thought to ask before it existed. With the one vehicle capable of real-time video from that depth now sitting in pieces on the Kermadec Trench floor, the team preparing for the Mariana Trench expedition later that year had to completely rethink their approach, and that forced change is exactly what set up the next strange moment in this story. If you're finding this as unsettling as I do, go ahead and hit subscribe. We're not done yet. The Landers and the Serena Deep, 2014. After the loss of Nerius, the Schmidt Ocean Institute adopted a new approach for its Mariana Trench expedition. Instead of relying on a single remotely operated vehicle with a live video feed, the team used several autonomous landers, large box-shaped platforms equipped with cameras, scientific instruments, and baited traps. These landers were designed to sink to the seafloor on their own and return only after completing their mission. Each lander had a specific task. Some carried cameras to record deep-sea creatures, while others collected rock samples, trapped small animals, or gathered sediment from the ocean floor to study the tiny organisms living within it. The landers descended nearly 11,000 meters into Serena Deep, one of the deepest places on Earth. Unlike tethered vehicles, these landers had no cable connecting them to the ship above. Once they disappeared into the darkness, the crew could only wait and hope they would return. After several hours, an acoustic signal was sent to release heavy steel weights, allowing the landers to float back to the surface. Not every mission ended successfully. During the expedition, one of the glass flotation spheres suddenly imploded under the immense pressure. Biologist Jeff Drazen later described the sound as being like an underwater explosion, and nearby instruments even recorded the shockwave echoing through the trench. One lander never returned, reminding the team just how unforgiving the deep ocean can be. Fortunately, the remaining landers survived and brought back remarkable discoveries. Their cameras captured swarms of tiny amphipods feeding on bait, but they also recorded something extraordinary: a pale, soft-bodied fish swimming deeper than any fish had ever been filmed before. Scientists, including Mackenzie Geringer, Thomas Linley, Alan Jameson, Erica Cusack, and Jeff Drazen, spent years studying the footage and specimens. In 2017, they officially identified the species as Pseudoleparis swirei, now commonly known as the Mariana snailfish. Despite living under pressures more than 1,000 times greater than at sea level, this remarkable fish survives thanks in part to a natural compound called trimethylamine oxide, TMAO. The chemical helps stabilize proteins inside its cells, preventing them from being damaged by the extreme pressure. Scientists believe TMAO is one of the key reasons fish can survive at such incredible depths, although many questions about life in the deepest parts of the ocean remain unanswered. What came after the human return? For more than 50 years after Piccard and Walsh's dive, no human being went back to the bottom of the Mariana Trench. Every trip in between belonged to machines: Kaiko, Nerius, the landers. That changed in 2012. Filmmaker and explorer James Cameron piloted a vehicle called the Deep Sea Challenger to the bottom of the Challenger Deep, alone, in a solo dive. It was the first time a human being had returned to that depth since 1960, and the first time anyone had ever done it solo. The vertical, torpedo-shaped design of his craft was a striking departure from the Trieste's blimp-like build, decades of engineering progress compressed into a completely different approach to the same brutal problem. Then, starting in 2019, undersea explorer and investor Victor Vescovo led what became known as the Five Deeps expedition, piloting a submersible called the Limiting Factor to the deepest point in all 5 of the world's oceans, including repeated trips to the Challenger Deep itself. For the first time, descending to the bottom of the Mariana Trench wasn't a once-in-a-generation event. It was something a single, reusable vehicle could do again and again, safely, on a schedule. But here's the thing worth sitting with. Even with humans back in the pilot's seat, almost everything that made real, ongoing science possible in this trench, the mapping, the sampling, the years of footage, the new species discovered, still came from unmanned technology. Kaiko, Nerius, the landers. The machines did the dangerous, repetitive, patient work that no funding agency could justify risking a human life for over and over again, for decades. The trench that nearly killed 2 men in a cracked steel ball in 1960 is, today, a place people visit on a schedule. But almost every mile of the road that got us there was paid for by machines that in more than one case never made it back. The pattern? Let's lay it all out one more time, back to back. A cracked window nearly stranded 2 Navy men at the bottom of the ocean in 1960. Kaiko's cable snapped without warning in 2003, and the most experienced deep trench vehicle on Earth simply disappeared. Nerius went silent mid-dive in 2014, and all that came back was floating debris. A lander's glass sphere shattered that same year in the Submarine Deep, its failure captured only as a sound on a hydrophone recording. And the same expedition that lost that lander also brought back footage of a fish nobody had ever filmed before, swimming calmly past a camera at a depth that should have been empty. Every one of those losses eventually got a real explanation, grounded in physics, in metal fatigue, in pressure differentials, not in mystery or monsters. There was no cover-up. Nothing attacked these vehicles. The explanations, once they arrived, were always mundane in the most literal sense. Cables wear out, glass has limits, pressure doesn't negotiate. But for a stretch of time before each of those explanations arrived, the people running these missions were left staring at a blank screen, or in 1960, a cracked window, knowing only that something 9 miles down had just gone wrong, with no way to find out why until the wreckage or the survivors floated back up. That's the real story here, not a monster in the dark. Just how much distance, physical and informational, separates us from the deepest place on our own planet. Piccard and Walsh's flatfish is still unconfirmed to this day. The Mariana snailfish, discovered decades later by a machine that nearly didn't make it back either, is fully confirmed, described, and named. The trench, it turns out, keeps a little bit of both proof and mystery every single time we go back down. If you want the next one of these, the moment it comes out, subscribe now. See you in the next deep dive.